Hi everyone, so we're going to look at some friction questions involving inclined planes. So this is bringing together a couple of topics that we've done recently. So here's example 1. A children's slide is inclined at an angle theta to the horizontal and a child of mass 25 kilograms goes down the slide, so there's our direction of motion with constant speed. And this is moving, so the child's moving, so friction's being overcome. So following on from that work that we did on friction, this means that friction must have reached friction max and then been overcome. And it slides down with slides down with constant speed. So constant speed there is really important. That means our acceleration is going to be 0 because the speed is constant. And we're asked to calculate theta given that mu, the coefficient of friction, is 0.5. So it's definitely a rough slide this because we've got a coefficient of friction that isn't 0. So let's have a look at this one. And here's the diagram for this just to start with. We've got our angle theta, our weight of 25g, and then let's put on some direction of motion and our reaction force and friction, etc. So first of all, we know that the direction of motion is going down the slide. So there's our direction of motion. There's our acceleration. And in this one, we do actually know the acceleration. And here's our important piece of information, constant speed, so there's no change in the speed, so the acceleration is 0. I'm going to put that on my diagram to remind myself that that's what's happening. The other things then that happen in here, it's definitely a rough slide because we've got a coefficient of friction that isn't 0, so I'm going to put friction on this, and if the motion is down the slide, then the friction is tending against the motion, tending to pull the child back and resist that motion down the slide. So there's my friction. Okay, and they're the only forces that are acting on this at the moment, on the child. The only other one we need actually is our normal reaction at the child because we've got these two surfaces in contact, the slope and the child. And don't forget, your normal reaction is always perpendicular to the surface there. So there's my normal reaction R. Okay, so there's my forces on here. And now let's have a think about answering this question. So we've got a force equation. We're going to be having a look at resultant force equals ma. And looking at this question, we're going to resolve our forces. The direction of motion is down the slope. So we're going to resolve our forces parallel and perpendicular to the direction of motion. So there are two directions. So to do that, R is fine because it's perpendicular to the motion. Friction is fine because it's parallel to the motion. So this 25g is the one that we're going to have to split up into its components. Okay, so let's split this one up into its components. Perpendicular and parallel to the direction of motion. If this is theta, this is 90 minus theta, so this one's theta. And then this component is 25g cos theta because this component is adjacent to angle theta. And then this component is 25g sine theta. And hopefully you're used to doing that bit of resolving forces now. So I've replaced this 25g by these two forces that are equivalent to this one overall. Okay, now let's have a look at doing our resultant force equals ma. So we're going to look, first of all, I'm going to look perpendicular to the motion. So perpendicular to the motion, and I'm going to take up away from the slope as positive. Just remember to tell the examiner that. And there's nothing happening in this direction. So perpendicular to the slope, there isn't any motion because this child is just going down the slide. So nothing's happening this way. So my resultant force equals 0. And my resultant force, then if I'm taking up away from the slope as positive, is R minus this 25g cos theta 0. So R is going to be 25g cos theta. So there's our first equation of motion there. Let's have a look then at parallel to the slope. And this time, because the motion is downwards, I'm going to take down the slope as positive. Okay, so there's my perpendicular. Here's my parallel to the slope. just put a little line down here to divide them up. So parallel to the slope, my overall motion is downwards. So again here, resultant force equals ma. But here the acceleration is 0, so actually here this is going to be 0 as well in this particular case. And my resultant force down the slope is 25g sine theta minus my friction is 0. Okay, and now I've got another little bit of working to do. I'm going to do that up here, I think. So up here now, my friction must have reached friction max, the limiting friction, because there is motion going on here. So friction's been overcome, friction's built up and up and up, and then it's been overcome. So that's going to be F max, which we know from last time is mu times R. We're told in this question that mu is 0.5, and we know now from down here that the reaction force is 25g cos theta. Okay, so now my friction here I can replace with F max, which is this. So I'm going to put that in here now. Keep going with solving this equation. So 25g sine theta minus my F max, 12.5g cos theta is 0. And now I've got a trig equation to solve sine theta and cos theta equals 0. So I can definitely get tan theta involved here by taking this cos theta and rearranging. And then sine theta over cos theta is tan theta. So dividing by the cos theta, dividing by the 25g, I'm going to get sine theta over cos theta is 0.5. So that's tan theta, which is 0.5. And then inverse tan of 0.5, 26.565. So theta, 26.6 degrees to 3SF. And that's question 1 completed. Okay, let's have a look at question 2. I'm just going to move this up. So question 2 now. We've got particle of mass m, so weight mg, sliding down a rough plane, again sliding down now, and rough, so there's a really important word there. Definitely got friction involved in this one. 20 degrees to the horizontal, and the coefficient of friction we're given as 0.2. Put that down here so I don't forget. Find the acceleration down the plane, so the thing down the slope. So the thing is moving, friction's definitely been overcome. Our resulting acceleration is down the plane, our resulting motion is down the plane. So let's have a little look at this. And we're asked this time to find the acceleration down the plane. So again, let's have a look at our resultant force equations. And let's put some forces on here. Just going to check what colours I used before. So green for reaction. And then my friction, this is tending to come down the slope, so my friction is going to be acting back up the slope. And again in this question, because motion is happening, friction has reached F max, so that's going to be mu r, so that's going to be 0.2 times whatever r is, and then I'm going to do some resultant force equals ma equations down here, parallel and perpendicular to the slope. So parallel and perpendicular to the slope again. Friction is fine, it's parallel. Reaction is fine, it's perpendicular. Let's have a look at splitting the weight into its parallel and perpendicular components. And once you get used to these questions, they're all very similar. It's just, getting used to them in the first place. So if this is 20, this is 70. I could use the 70 there, but I'm going to use this one just because if this is theta, it's much easier to use theta here rather than 90 minus theta. But we do get the same answers. So if you wanted to use 70 there, that's fine. But this is 20, so this is 70. So this one is 20. And then this component is adjacent to my 20 degrees. So that's going to be cos 20, mg cos 20. and this one, which would be this vector in this right angle triangle, is mg sine 20. Okay, let's have a look then at our perpendicular, oops, let's get the black going, perpendicular to the plane first of all. And again, I'm going to take up away from the plane as positive. And perpendicular to the plane, there's no motion in this direction, so my resultant force is equal to 0. So I'm going to get r minus mg cos 20 is equal to 0. So r is equal to mg cos 20 degrees. And now that can go up here. That's gone up there now. And then let's have a look at parallel to the slope. And again, because my motion is downwards, I'm going to take down the slope as positive. Tell the examiner we're doing this, and it's also good to remind yourself when you're doing your resultant force equations. Resultant force equals ma. It's not 0 this time because we have got acceleration, that's what we're asked to find. So resultant force down the slope, mg sine 20 degrees minus my friction is going to be equal to m, the mass is just m in this case, times a, which is what we're trying to find. Okay, so now what we've got a couple of equations. Perpendicular to the slope has given me this expression for r, which I can sub in for f max, and then in here my friction is f max in this particular case, so this can go in here. So let's have a look then at carrying on with that part of the question. So mg sine 20 minus 0.2 mg cos 20 is equal to ma. I want to find out what the acceleration is, so I'm going to divide by m all the way through, and then this is going to give me my expression, or my value, for acceleration. So let's have a look. We've got 9.8 sine 20 9.8 sine 20 minus 0.2 times 9.8 times cos 20, and we're getting there 1.5099. So A is equal to 1.51 meters per second squared to 3SF. Okay, I'm going to pause there then. I'm going to stop the video. I'd like you to get these two examples into your notes, please. And then I'll do two more examples. The next two examples are a little bit bigger. So I'm going to do two more examples in the next video. And again, I'd like them to go into our notes.